Hi everyone, and welcome back to another exciting episode of Programming for Engineers. So in this video, we're going to continue on with our programming review. I would expect that this material looks very familiar to you, but it's also extremely important because we're building a foundation building these fundamental building blocks of programming that we're going to be using constantly throughout the semester as well as in other courses. So we want to make sure that your foundation is rock solid, so that we don't move into additional material and have issues with building upon this. So it's definitely worth spending the time in clarifying any sort of misunderstandings that could be in place related to this material before we move on to things that you haven't seen before. So we're going to talk in this video, we're focused on for loops. For loops is a type of iteration. All right, so it's an iteration, and let's look at this in the context of an example. If we were going to look at this example below, what this effectively does is this prints a bunch of numbers. It prints 0, 1, 2, 3, all the way up to 9. All right, so if we look at that, this would be equivalent to having 10 printf statements outside of a loop where we print 0, print 1, print 2, all the way up to 9. Okay, now loops, this type of iteration is exceptionally important because all the time, constantly, we're going to have logic that we need to be able to have loops, because we frankly don't want to have to just have this massive amount of code where we're having things copy and paste, as well as we're going to have the loops depend on a variable, so the number of times things iterate varies based on the logic, based on some values for variables. So more on that in a little bit. So what we want to do is let's take a look at a for loop, and let's look at how we want to break this out into 4 components. Okay, we want to break this out into 4 components. We have an initialization piece, a condition piece, a step, and the body. The body is the code body, everything in the curly brackets. Okay, so let's take a look at the order in which certain things happen, and then we're going to trace some examples to make sure we have a really good understanding of what is going on when we're dealing with for loops. Okay, so first let's look at this example here. Okay, let's look at this example here, and let's kind of trace through what's happening. And I'm going to do this by first looking at a flow chart diagram so that we make sure that the logic that we're using here, that you have a bit of a visualization behind it. So the first part here is the very first thing that happens. We have this initialization piece, right? That's the initialization piece, and we can think of when we go into a flow chart for a for loop, one of the first things that's going to happen is we are going to hit the initialization. Okay, and I'm just going to draw it like this. Okay, just initialize, right? That's the I equals 0. We're setting I equal to 0. Okay? Right. The next thing that happens is we check the condition. We check this condition. This is a true or false statement. We're determining whether or not that condition is true or false. Right? So let me just kind of I'm going to write this as check condition. Okay, if the condition is true, we're going to enter the loop body. Okay, and if it's false, we're actually going to leave the loop entirely. Okay, we're going to exit the loop if the condition is false. Okay, after we run the loop body, we're going to deal with our increments. Okay, this is the increment here. We're adding, in this case, it's showing that I equals I plus 1. So we're adding 1 to I. Okay, so this is our increment. Okay, and after the increment, we're going to run back up, and notice we kind of have these arrows forming a loop. Okay, so we initialize, check the condition. If the condition is true, we go into the loop body, then we increment, then we check the condition again. Okay, so we're going to continue going around and around and around, okay, until the condition's false, and then we leave. Okay. So for loops are really good for counting things when you have the increment dependent on a you know, a constant step. Usually adding 1, but doesn't have to be. Okay. So in this case, well, what does this do? We kind of already talked about this. This is going to go 0, 1, 2. It's going to print out all of those numbers up to 9. Okay, up to 9. Now, one little thing to keep in mind, right? If I ask the question, what is the value of I after this code runs? Okay, it's actually not 9. Okay, it's 10, right? Because this code fails when we check this. The condition fails when we check we ask the question, is 10 less than 10? That's false, right? They're equal. It's not less, they're equal. That's false. I is equal to 10 at that point. So it's notice that that's the, you know, it doesn't fall into the code body, the loop body at that point, right? But at the end of this loop, right, I is actually equal to 10, not 9, right? That's just a you know, important point to kind of emphasize. We don't have to have the loop increment by 1. It can increment by other numbers. Okay, it can increment by, say, 2. In this example, notice that this is incrementing by 2. Okay. By the way, really just minor point here. It's also an important thing to note, and I think it'd be very easy for me to skip over this later on, so I'm going to mention it now. Here we're incrementing by 2. If I go back, here it's incrementing by 1. Adding 1 is a super common thing in programming. Okay, adding by 1 is a very common thing to happen. This could also be written as that. Okay, I plus adds 1 to I. Okay, adds 1 to I. Very common, since it's so common to add 1 to something. It's very common to see it written that way. Okay, and you're going to see me doing that later on. You're going to see examples doing that, and just keep in mind, you know, what that means. Okay, if we wanted to subtract 1, we could do minus. Okay, it's the same idea. All right, going back to this example here. All right, this will be really similar to the last one. Well, what's this going to print? All right, this is going to print all the even numbers. Okay, it's going to go 0, 2, 4, 6, 8, and it's actually going to also print 10 because notice this is saying, hey, while I is less than or equal to 10. Okay, so it's going to, this is what we're going to get as a result. Okay, and I also want to point out again, if I said, well, what is the value of I after this runs? Okay, in this case, the value of I is 12. Right? Because when the code fails or the condition fails when we ask, is 12 less than or equal to 10? Okay. One also, you know, minor point to mention, that's very often that we don't declare the variable outside the loop. We could also declare it right here. Okay, int space I. You can do that right there as well. Okay. Very often you see it that way. All right, last example for loops, and we'll keep this video nice and short and sweet. We could, you know, there's no reason why we can't count down. I want to point out there's other types of loops, things that you should have seen in the past that we'll talk about later on. In the next video, we'll look at while loops. Keep in mind that there's a time and a place for using different types of loops. I just want to emphasize that, as I mentioned before, for loops tend to be very good at if you're basically, you know, you're incrementing by some sort of fixed amount. You know, if you're counting and you want it to loop a certain number of times. So they, you know, the fact that they break up the logic and they have, for loops have this increment component to them makes it very good for those when you have a kind of a defined constant increment or decrement that's happening every time you loop. Okay. Now, if we look at this, we say, well, what is this going to do? Notice there's no reason why we can't count down. All right. In this case, we start initializing at 20. Okay. We go to I is greater than or equal to 20, we're going to continue to loop while that's true. So this is going to print out all the even numbers counting down, okay? It also prints 0 because the condition's still true. If 0, if I is 0, 0, if we ask is 0 greater than or equal to 0, well, that's true because they're equal, okay? And at the end of this loop, this is what we print to the screen, okay? But at the end of this loop, well, what's the value of I? Well, the value of I is actually -2. All right, because that's the time when this loop fails. We say -2 greater than or equal to 0. That's false. We leave the loop. Okay. All right, I'm going to stop this video here, and we'll continue on and have a separate video where we look at while loops. All right, so we'll continue this review looking at another one of those important constructs in the next video.